kinds
This
of
conference will now be recorded.
warehouses in the market. When you talk, when we look at the on-premise, so we have big data, we have Hadoop, we have Teradata. These are the on-prem data warehousing solutions. But when it comes to the cloud. So we have Redshift for AWS, we have Databricks for Azure, we have BigQuery for Google, and Snowflake is itself a data warehousing solution. Okay, so these are the various kind of data warehousing solutions that you have in the market. Okay, Snowflake has came into the market in between 2012 to the 2014. I mean, they have announced their product in 2012 and they have gone live in 2014, and it became very popular in India, especially in India, just before the start of the COVID. The time when
Share
all
the
the
screen,
businesses.
sir. Share the screen.
Not sharing any screen as of
Okay.
now. Uh, okay, I'm not sharing any screen. I'll share soon. Okay. So this is the time when all the businesses are moving towards the digitalization, and they've chosen Snowflake as their data warehousing solution. The reason why they're choosing that we'll be discussing soon. Okay, but this is the overall the history of the, I mean, not the history of the Snowflake, how it has evolved. Okay, so currently Snowflake is number one in the market, and it has beaten all the cloud-based warehouses. Okay, just before I mentioned them. Okay, so it is the number one in the market with respect to market capital and acquiring the clients in every aspect. Okay, so
Sorry to
So your
interrupt.
voice
Like
is
there is
breaking actually.
disturbance
Not
in
sure
voice.
whether it is only for me.
okay,
There is disturbance in voice.
this
Yeah, yeah,
show is
correct.
okay. How about now? I just changed my network.
Okay, go ahead.
Hello?
Yeah, yeah, you can continue.
Yeah, is it still same or is still getting scratched or any kind of distortions?
No, 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 now it looks good actually.
Okay. Okay. What's the reason behind using a data warehousing solution? Why do we need to use a data warehouse? Okay. The reason is we have a database, RDBMS system that we used to call, and we have data warehouses. Okay, so all the RDBMS systems we call them as OLTP systems. Okay, online transaction processing systems. Okay, they are designed in such a way that they will capture the transaction swiftly, very fastly. For example, when you go to any kind of shopping mall, or when you go to any kind of retail stores, retail grocery store, or if you go to any kind of ADM, so whatever the systems you see over there, they are OLTP systems. The applications are connected to the databases, relational database management systems. Okay, it could be Oracle, it could be SQL, it could be PostgreSQL, anything. Okay, so the reason is whenever the person at the counter is entering the data, so the application should write the data into the database. Okay, they are designed in such a way that they'll have faster write operation, all the OLTP systems, because they have to capture the transactions very fastly. Okay, now since the OLTP system does not have, they will not have unlimited amount of storage, because if your storage gets increased, your application performance will be degraded. Okay, they are inversely proportional to each other. Okay, you have to keep your storage and the data as short as possible. Okay, for that purpose, what the organization will do is they'll shift the data from your OLTP system to the OLAP system. Okay, OLAP system is basically an online analytics processing systems where you will have unlimited amount of storage and you can store unlimited amount of data in your OLAP system. Now, why do we need to have an OLAP system? Okay, so for example, the organization or a Reliance store, let's take a Reliance supermarket as an example. He wants to perform analytics. Okay, so he used to have stores across India. Okay, so he wants to perform the analytics on the stores present across Hyderabad. Okay, how much sales are going on, what products are going well, what products are getting profit, and what products are running into losses. Okay, how many people, how many staff working, how much of amount of salaries are going on. So he wants to calculate all this kind of details. He want to know all this kind of details. Okay, for that purpose he need to have we need to have historical amount of data, not just 1 month of data or 15 days of data. Okay, so, and how do we get that historical data? So we'll ship all the data from your OLTP system to OLAP system on daily basis, or on every 15 days or every 30 days, like that. So batch processing. So we'll ship the data and we'll store the data for years and years. Okay, on that data, so we will perform the analytics. So and we'll give the data to the executives. Okay, so whoever requested the data, so we'll write a SQL statement to that to match that requirement, and we'll extract the data from your data warehouse, and we'll provide the data to the uh, executors. So this is the purpose why we use data warehouse. Okay, to perform your analytics. That's why we call it as online analytics processing systems. Okay, not just this analytics, but data visualization are basically we call that as a reporting purpose. And also nowadays AI is becoming more popular. Okay, so how AI is developing is that they are developing a large language models. Okay, the data scientists or machine learning scientists, what they're doing is uh, they are developing these models based on the data that we provide. We as a data engineers, we as a Snowflake data engineers, or we as a data platform team who manages the data across the organization, across the multiple data sources. Okay, we will be organizing your organization data. Okay, and we will keep it with ourselves, and we'll expose the data to the downstream teams. Okay, and one of the downstream is that machine learning teams or data scientists. Okay, they will uh, consume our data. Okay, historical data, and they'll train their models. How much the data is accurate, their models will perform that much accurately. Okay, it's not that the models will perform 100% accurately. Okay, so that's how these are the use cases basically why we want to have a data warehouse. Okay, so basically we are acting as a middle layer. We are providing a data platform to your data sources across multiple data sources in your organization. When we talk about multiple data sources, it could be your OLTP systems, it could be our SFTP servers, it could be our any kind of cloud storage, or it could be anything, any kind of source that you take. Okay, so we will be extracting the data from those multiple sources and put it in your data warehouse. Okay, and expose the data to the downstream teams. Okay, here data warehouse will stand as a middle layer. Okay, it acts as a middle layer between your sources and targets. Okay, that's how the usage of warehouse comes into the picture. Okay, and now why do we have a warehouse dedicatedly? Because to handle your historical data, to handle your huge amount of data, you need to have unlimited computational power. I mean, when I mean to say unlimited compute power, you need to have your RAM and CPU very higher. Okay, to process your historical data, to read your historical data. Okay, so that's why which cannot be obtained from your on-premise servers. Okay, because they need periodic maintenance. Okay, so that's why cloud-based solutions will provide you the unlimited compute power as well. Okay, that's the reason we are going with Snowflake data warehouse. Okay, Are you guys clear so far or have any questions? Ramesh and Akshay. Let me take a pause here and see if you have any questions.
Nothing as of now.
How about you, Ramesh? Are you
Yeah,
good?
yeah, Chandra. Nothing as of now.
Okay. Let me share my screen. Okay. I hope you guys able to see my screen, right?
Yeah, yeah, we can see.
So any cloud service provider, will offer their services in these three segments. One is infrastructure as a service, one is platform as a service, and one is software as a service. So when we talk about infrastructure as a service, what comes under infrastructure as a service? It's the virtual machines, the storage, the network, the security, all these kind of things that we call as the infrastructure to run your application. Okay, so they are provided under infrastructure as a service model. Okay, and when it comes to the platform as a service, okay, the database that is required, okay, the other stuff that is required to run your platform, those are provided under platform as a service. Okay, so when it comes to the software as a service, what the cloud providers will do is, they will procure the license from the software company, and they will give you the access to work on that particular software. Okay, for example, ServiceNow. Okay, so what ServiceNow, what cloud providers will do is, they'll procure the licenses from the ServiceNow, and they will provide you the ServiceNow as a software as a service. Okay, AWS will provide ServiceNow as a software as a service, Google Cloud and Azure, Microsoft Azure. So all these major cloud providers will provide ServiceNow as a software as a service. Okay, so these are the three different kind of service models that we have. If you look at any kind of cloud providers, these are the service offerings they'll provide. Okay, and now when it comes to the Snowflake, it's a software as a service model. It's truly a SaaS application, because they only have their application. Snowflake, I mean, Snowflake is itself an application, and Snowflake is itself a data company. Okay, company name. Okay, they only had these applications, just like how ServiceNow has a ServiceNow, or a Talent has Talent, any other Power BI has Power BI, like that. So this company's Snowflake has their application, Snowflake, and they are providing the service in a third model, in a software as a service model, through offering that. Okay, so what will happen with software as a service? Okay, we'll see that. Okay, this thing, uh, infrastructure as a service is the delivery of the technology infrastructure. Okay, which requires the basics that to run your application: virtual machines, virtual storage, networking, security. Okay, security, everything. Okay, firewalls, everything. Okay, so this is what they'll provide in infrastructure as a service. Okay, and when it comes to the platform as a service, it's a service where they provide the platform that is required to run your application. Okay, be it be Apache servers, web servers that we used to call them. Okay, so this is one offering, and this is
Your voice is breaking again, Chandra.
okay. I don't know what's happening with my Hello. Hello.
Yeah, yeah.
Akshay, are you there?
Yeah, I'm there.
Okay. Okay. It's a software as a service company. Okay. Where they're providing a SaaS model, software as a service. Okay, for example, you can take your OS as an example, you can take ServiceNow as an example, you can take Snowflake as an example for this kind of service model. Okay, software as a service. Okay, so this is how the provider will provide. When you go to the infrastructure as a service, the OS data application will be taken care by the customer itself, and virtual servers, storage, networking, all this will be provided by the provider, cloud provider. When you talk about provider, it's a cloud provider. Okay, when you go to the platform as a service, including OS and database and everything will be provided by the provider, and you have to manage your application and your data. Okay, when you go to the software as a service, everything will be taken care by your cloud provider. Okay, you need not to bother about your storage, you need not to bother about your compute power, you need not to bother about anything at all. It's near to zero maintenance. Okay, so all you have to do is you have to concentrate on your running your operations in Snowflake. Okay, so there is no maintenance. Okay, zero maintenance. So say patches and everything will be taken. The maintenance will be taken care by the Snowflake vendor itself from the back end. Okay, so there is no downtime at all to update or upgrade your software like that, like how we do in the on-premise servers. Okay, so this is where the comparison between the on-premise and cloud computing. So on-premise will have more cost involved because to design your application, you need an architect to design your infrastructure, which could be higher than the cloud model. Okay, and it requires a periodic maintenance as well. Okay, so you have to put it in, you have to provide the network, you have to provide the OS, you have to maintain the teams, you have to continuously monitoring the server. Okay, and fail so not just maintaining a standalone server, you have to maintain everything in a cluster. Okay, to take care of your disasters and all. Okay, which involves heavy initial cost, initial capital. Okay, that we used to call. But when it comes to the cloud, Snowflake computing, so you need not to have any upfront cost. You can simply create an account and start using the services of your Snowflake. Okay, so there is no upfront cost that you need to put up. Okay, and control, so you have a better control on your resources in cloud. So you need not to worry about the setup and everything, you need not to install anything, you need not to install patches, whatever that is required, because everything will be taken at the back end by the vendor. But when it comes to the on-premise, you need to control more, you need to maintain your server. Okay, from time to time. Okay, your on-premise server in your data center. Okay, so these are the various differences that you see between on-premise and cloud computing. Okay, the flexibility, so you have less flexible, I mean less customization that is available in the cloud-based warehouses, because the customization will be taken care by the vendor again. So you have more flexibility to run your operations. Okay, and whereas when it comes to the on-premise, so everything customizations, everything will be dependent on you. Okay, we have to maintain everything. Okay, we have to customize our application, we have to customize our needs, we have to customize our servers and all. So that leads to less flexibility to use your on-premise data warehousing servers. Okay, So I'll take a pause here and see if you have any questions over here. Okay. So this is what the definition. Snowflake is an analytic data warehouse, which is offered as a Snowflake software as a service model. So which runs on the SQL engine. Okay, whatever the Snowflake has built on an SQL engine. Okay, so which it supports SQL, the standard skills. It supports JavaScript. It supports Python. It supports PLSQL. All these languages Snowflake can support. Okay, I'll take a pause here and see if you guys have any questions here so far.
So like Chandra, what kind of data Snowflake will support in comparison with Redshift?
Sorry, volume of data.
So,
What type of data?
Oh yeah.
Structure.
So Snowflake is very diversified. It can support six different types of data. Okay, six different types of data formats. One is CSV, JSON, XML, Parquet, Avro, ORC. These are the six different types of data types that you have in the real time world. Apart from these data types, you will very often unusual to get your data types. Apart from these, it's most of JSON and CSV. So apart from that, it can support XML, Parquet, ORP, JSON. I mean ORC, Avro. So
Yeah, so all these are semi-structured data types,
yeah,
right?
exactly. Except
So like,
your
like, uh,
CSV. Yeah,
my
except
question
your
is so what type of data it can support in comparison with AWS Redshift? So what I
so
mean to
far.
say is
Yeah, I understood Akshay. So far, we have discussed about the structured data and semi-structured data. Okay, what the real thing is, Snowflake supports the unsupported data as well. Okay, so it can support the PDF files. Okay, you can load your PDF files into the Snowflake. You can images you can load into the Snowflake. Images PDF. These are basically called as unstructured data. Okay, Snowflake can support these type of formats as well, and unfortunately Snowflake cannot support the video files as of now. I'm not sure if Snowflake has introduced that feature or not, but I have to check on that. But when it comes to the unstructured data, so PDF and this thing, so when you talk about data, Akshay, what do you mean by data?
so in
Volume
my
of data.
experience, no, no, like I did some application development with respect to integration with some L1 and L2 level
Mhm.
integration as well, where we will be getting a lot of unstructured data from the real-time IoT devices and all those things.
Okay.
So yeah, so what I know is Redshift will support all those things like from iPad, you can operate it from iPad and you can just get all the real-time machine insights and then it will
This
be loaded in the
Snowflake
AWS.
supports real-time streaming data as well, Akshay. Be it semi-structured, be it unstructured, be it structured. Okay, Snowflake also supports streaming data. Your streaming data can come from anywhere. Okay, be it iOS, IoT devices, be it your web applications which generates your streaming data, be it Kafka and Zookeeper, which can send the real-time messages. So you can capture your streaming data. Okay, you can clean your data before you can load your data into the Snowflake. You can clean your data inline. In the process of copying the data into the Snowflake, you can organize your data and you can load your data. So such kind of customizations in your operations are available. You can do that.
Okay, yeah, thank you.
Yeah. Any more question, guys? So our responsibilities, being a data engineers or Snowflake developers, our responsibility mainly lies in developing the data pipelines and converting the business requirements into the uh, SQL codes and all. Okay, these are our main job requirements. So when I say designing the data pipelines, okay, so you have to find a way how you can extract the data from your source. Okay, and you have to automate that on a daily basis. Okay, so for example, you have data coming from your database, so you have to find a way in such a way that, so you have to extract the data from the database on daily basis, and you have to transform the data, or you can directly load into the Snowflake and you can transform the data within the Snowflake. Basically ELT operation, instead of ETL operation you can perform ELT operation. Okay, so our responsibilities lies in designing the data pipelines, and of course maintaining that robustic data pipelines. Okay, so likewise, when you have different data sources, you have to design different data pipelines. Okay, so
So, Chandra, tables and schemas will be under our control
yes,
for each
tables
and
and
every
schema.
application.
Yeah, so we will be controlling our databases, our our schemas, our tables and everything. Okay, whatever in the source side we don't have any control. Okay, the source team will be taking care of that. The minimum level of access that will be provided to us. Okay, but when it comes to the Snowflake, we will have 100% authority, we'll have 100% control on our data. Okay, we can play with our data. Okay, source side you will not have that level of control that you have on Snowflake. Okay,
Okay.
so that's what. So SFTP servers, if you have your data coming into your SFTP server, you have to find a way how you can export the data into the Snowflake. You can write any kind of bash script or any kind of script which exports the data, which copies the data into the Snowflake, and from, I mean, not directly into the Snowflake, but into the S3 bucket, and from S3 bucket we can copy the data using the real-time data loading functions available in Snowflake. That's how you can design your data pipelines, continuous data pipelines. Okay, so so any questions, guys, so far? So I'll be explaining you. I'll be sending you the curriculum as well. That we'll be discussing in coming days. So let me share the curriculum as well. Okay, since this curriculum is basically okay, designed to handle I mean, experience level of up to 7 years. Okay, 6 to 7 years, guys. But you guys are more than that. But that's okay. We can go with this curriculum, and so these are the different types of topics that we are going to do. Introduction to data warehousing, SQL. We'll see a bit of basics of the SQLs. I hope you guys are already aware of these functions, SQL things, and everything. Joins, functions, all this, and we'll discuss the features of the Snowflake. And first initial 3 or 4 classes will be of more descriptive in nature. Okay, where we'll be discussing the architecture, I mean the functionality of the Snowflake, how it works, and massively parallel processing and micro partition, how they help in improvising the performance. Initial 2 to 3 classes will be of more in descriptive nature, but from there onwards, the classes will be like uh, explanation of the feature, and followed by its lab sessions. Okay, from day 4 or day 5 onwards we'll be having this features and lab explanations going on parallelly. Okay, during in between sessions, I'll explain the use cases that we worked on, okay, for our customers. Okay, I'll explain how we have designed the architectural architectural patterns, what technologies we have used, what technologies we have incorporated, all this kind of stuff. I'll explain by taking a use cases so that we can have a better understanding why we will be using this Snowflake. Okay, sounds good.
Yeah, yeah.
Yeah, yeah.
All right.
So we
Uh,
need a scripting knowledge also, right? In that case.
See, scripting, it depends on case to case, Ramesh. Okay, so SQL is a must. Okay, to be in order to be a developer. Okay, script skill knowledge is must. But if you want to be an admin, or if you want to be or a data engineer, okay, you can have minimal scripting needs. Okay,
Okay.
okay, where your 30% your work will be on the skill, but rest of your work is on the features of the the features of the Snowflake. Like you have to control your role-based roles. Okay, you have to control users, all
So
this kind
how
of stuff.
often should we need to have a basic knowledge of Python here?
Python is good to have. Okay, Snowflake supports Python as well. Okay, it's good to have, but unfortunately, we are not going to cover Snowpark, which is a Python libraries for Snowflake. We are not going to cover in this curriculum, but it's good to have. Okay, if at all I get any chance or at any time, so I'll discuss a couple of things related to the Python as well. Okay, in between
Okay, so like what I know is like most of the companies are using these pandas in
pandas, yeah.
integration with, yeah.
Yes, I agree that actually, unfortunately, Snowflake supports minimum of pandas. It relies minimum on pandas, but like I mentioned, Snowflake has its own library for Python. That's called as Snowpark. Okay,
Okay.
it's a library, Python library that you can find it out. Uh, so pandas also Snowflake supports, but in real time we use very less. I'm not sure about how we do in other stuff. I mean, or Redshift or something. But in Snowflake, we have a dedicated library.
Okay.
Okay, that's all, guys, for today's demo session. Do you have any questions? You can feel free to ask me. Okay, so questions related to how the career will be in Snowflake, or any kind of questions, how the packages will be, how the openings are across the market.
Yeah, can you describe on that, please, Chandra?
Describe on what I mean. If you could
Like how the openings on
openings,
Snowflake
we
is.
are uh, in our organization at least, we are facing a lot of struggles to hire the right talent for the Snowflake. We have a really shortage. Okay, in Snowflake talent, we are hunting the talent from last 1 year to hire at least 150 people across various levels. Okay, that same in the other organization as well. If you look at the Accenture, if you look at the Capgemini, if you look at TCS, you can go to LinkedIn to find out what kind of jobs they are posting. They are posting more of jobs related to the Snowflake leads, Snowflake managers, data engineers who has exposure into the data world and all. Okay, and with respect to the packages and all, you if you are a right fit to their role, no company will negotiate you on that part. Even I've seen a cases who got 100% hike, 120% hike. I myself got 110% of hike when I joined the big four company. So that's how the market will be. Okay, so put your right skills in your resume, or present it to your technical team, who you are interviewing and all. So that's it. So I'm myself taking daily 4 interviews in my organization, but unfortunately a lot of people's do not possess the enough skills. Okay, so I do not have any other choice other than rejecting them. So that's how. Okay, you'll have the positions varying from 3 years to 12 years. Okay, range 12 years, 14 years also. You can find the roles related to this experience in the market. So you can explore LinkedIn for your better understanding on the positions.
So one question here. So like I have a blend of mixed experience with other technologies as well.
Yeah,
So like
that's really
the
that's really
relevant
great
experience
actually.
with the Snowflake will be minimal for me. So in
Yeah.
comparison that, so will it be considered?
So you have to be act little smart, Akshay. Okay,
Yeah.
so having a multiple experience on the multiple technology definitely helps. You have to portray it in such a way that you have to convert your Redshift experience into the Snowflake experience. Okay, because like I mentioned, most of the features are similar across all the warehouses. Okay, suppose if you learn Databricks, okay. So not just
Yeah.
Snowflake. If you learn Databricks, you have to be smart enough, to convert your Redshift into Databricks. If you find more positions on Databricks, okay. So and you have to explain the things how is happening in Redshift, keeping your Databricks in mind. Okay, so you have to convert that.
Okay.
Okay. So when
Okay.
I
Okay.
started my career, not career, I started with the Redshift, okay, and of course, parallel I was working on the Snowflake as well. But down the line, I've converted my Redshift experience into the Snowflake because I see the boom in the Snowflake, and the openings are happening, how the openings are happening across the Snowflake, and I converted that Redshift experience into the Snowflake. I know how the architecture of the Redshift, how it happens, how the massively parallel processing will happen, how we can create the nodes, okay, in Redshift and all. Okay, so that's how you have to convert that. So keep that in mind. Okay,
Okay.
so all right, guys, let's wrap up for today. I'm not sure how the classes are scheduled. So you guys can check with Prakash. I've already given my availability to Prakash on weekdays. Okay. If you guys have any questions, you can reach out to Prakash as well. Okay. Thank you, guys. We'll see you tomorrow then. Closing this call.
Thank you.
Thank you.
Thank you.